Hi, it's Kathy from Fieldwork Connections. I am on the mid-north coast of New South Wales at Smiths Lake, and we have had a lot of rain over the past few days. I think they probably would have got maybe 100 mils overnight up here, so the lake is very, very full. Some may call this a coastal lagoon from a geographical perspective, or if you're thinking about coastal management, you might call this an ICOLL. So an intermittently closed and opening lake or lagoon. That's what that stands for, ICOLL, ICOLL. And when we're thinking about geography with ICOLLs, most local councils will have management plans for them, because even though they are a beautiful natural feature of the environment, used by many people for recreational purposes. You can see some fishermen there behind me. There's also many social issues around them, because if you have development around the lagoon, maybe houses, I know that we have a campground nearby where we are staying tonight, people can have issues with the lake being closed to the ocean because it can become stagnant. The water coming down the system is not very nice. So as part of a management plan, local councils will open up the ICOLL through the barrier beach, and what you can see here behind me here is that barrier beach, the strip of sand separating the ocean with the lagoon. And at some point they will decide when it is time to open that up and let all that water, or as part of the natural system, if we get even more rain, you can see the lake has come up a lot in the last 24 hours. I know this because I was here a few weeks ago. It will just break through on the next high tide, and all of this water, the brackish water behind me, will rush out to sea, and that will just be part of the natural processes in this coastal system. Quite often you might be studying coastal systems in Year 10 geography, and if you have a local coastal lagoon or ICOLL in your area, there are many kinds of tests that you can be doing. And tomorrow I'm going to head out and take my refractometer to have a look at the levels of salinity in Smiths Lake, to see just how much fresh water has been coming down the catchment from all that rain. And I have my water probe as well to test for the pH concentration in that water as well. So here, from a different perspective on the other side of the lake, you can see just how full it is. But over there on the far side is the barrier beach. It doesn't have any sand dunes in the middle of it, and that is currently closed, so there is no channel. But overnight, if the water from the catchment keeps flowing in, and on a high tide, we might find that in the morning all of this has drained out to the ocean and the level is much lower. We've come up to Wallace Lake, which is the next lake north of Smiths Lake, and Wallace Lake is actually open to the ocean at Foster. So what I would like to do is a comparison between the salinity in the lake at Smiths Lake and Wallace Lake after all this rainfall that we've had, because we're expecting that there will be quite low levels of salt or salinity, and I'm going to use my refractometer to be able to test that. So you can see the water's just coming in here. I'm going to just carefully put the end in, allowing there to be a nice film of water across the plate and the cover on. And then I'm going to hold it up to my eye to a bright area of the sky and take the reading on the right hand side. And what I am seeing, it is 25 grams of salt per kilogram. So that is parts per thousand that's measured in. So what that means is that when we have 25 grams of salt per kilogram, in water, that is less than seawater. So we know that there is fresh water entering this system, because seawater has between 35 to 40 grams of salt per kilogram. These coastal environments, these ICOLLs, are adapted to the fluctuating salt levels, and so even though we can see there are beautiful melaleuca and casuarinas growing along the shores of Wallace Lake, they don't mind if it's a little bit saltier or if there's more fresh water coming into the system. It's all just part of the natural environment. I'm also going to do a pH test using the pH probe, and that is going to give us an indication of the comparison to seawater. So seawater, the pH is slightly alkaline, between 8.2 and 8.4. Remembering the pH scale is going from 0 up to 14, 0 being acids, strong acids, 7 being neutral, fresh water, and 14 being alkaline, heavily alkaline. So what I'm going to do, what have I got it set on? It's currently set on turbidity. So I'm just going to scroll through by pressing this bottom button. There we go. Now I've got it on the pH setting. It's actually a little bit hard to take here because we've got the waves coming through. So ideally, we probably want to take this by putting a sample into a small jar. Yeah, it's falling. I've got 7.4, so it's less than seawater. So this is just confirming that our salinity level being low, lots of fresh water in this system, also has a more neutral pH, 7.3. Well, I'm back at Smith's Lake and it is almost high tide. So here is the lake behind me here, and here is the ocean. And the waves are coming up, you can see just here, but I just don't think they're going to be quite high enough on this high tide to be able to break through to this very full lake. But I'm going to wait around and see what happens, and maybe do a spotted fishing in the meantime. Alright, so I'm just going to try and collect a sample of the salt water coming from the ocean. So I've got my sample of salt water on the plate, and I'm just going to take a reading. It is reading 35 grams of salt per kilogram, just as we'd hoped for from the ocean water. Now I'm going to compare my ocean water sample with the lake water, and just remember we are getting a little bit of infiltration from the ocean here. I've taken my sample in my refractometer and I'm going to have a look at the result, and it is reading 30 grams of salt per litre, so it is slightly diluted compared to the ocean water, but we still can see that it is from this lake system which has been getting that influx of rain.